Hey everybody, welcome back to Everything Functional, the channel where I talk about and teach about things relating to modern Fortran. In this video, I wanted to show an example of how I put together Fortran projects to take advantage of the tools and automation for projects that I host on GitHub. I'm going to show you the example project and all of the kind of infrastructure that we can put together around the project using the automation tools available on GitHub and to make our real lives easier and make our projects kind of more professional looking and polished when we make them public and publish them and point people to them. So let's jump over and we'll take a look at the project itself first. So what we're going to look at is a very simple Fortran library project. This is just kind of a contrived example just to demonstrate some of the capabilities that we're going to talk about. Uh, so I have just a simple library here. It's just got one module. It's got one function in it that just does create greeting. The comment here uses the special double exclamation point to start the comment. And this is actually something that the Ford documentation generation tool is going to pick up on. So this is specifically documentation that will be extracted and generated for us automatically. So that's what this is here. Um, but then the greeting function is just a simple concatenate hello and an exclamation point so that we can create a greeting for somebody, right? And then for any good library, you're going to have tests for it. So we have a simple test program that we keep in the test directory. So the library itself goes in the source folder, and then the tests go in the test folder. Ordinarily, I would use some testing framework of some sort to, maintain and automate a lot of my tests. But for this simple example, we can just get away with a simple single Fortran program that just executes our code and makes sure that it works correctly. Right? So we're just gonna use our function, make sure we get the answer we expect, and either set, tell that we passed or stop because we failed. So that's the basics of what the project consists of. So now we'll start talking about all of the automated tools that we're going to use. The first one is the Fortran Package Manager. So to take advantage of the Fortran Package Manager, all you really need is a single file fpm.toml, and this is all the contents you're going to need. Ordinarily, most of my projects are going to have an additional section here that defines all of our dependencies, but since this is such a simple project, we don't have any dependencies and we don't need those sections. There's lots more to learn about FPM, but that's a little bit beyond the scope of this video. Just know that it's a very powerful tool that is really catching on. And so if you're interested in all, make sure you go and learn more about that. I'll put a link in the description to where you can go start looking around and learning about FPM. Next, every good project should have a README. This is the file that GitHub will display by default on the front page of your repository. And so you want to have a nice, concise README that kind of gives an overview of what the project's about and provides links to any of the relevant references that you may have. So for this one, it's just a simple example, right? And this is using Markdown named readme.md, and it uses Markdown syntax to write documentation, right? And you can provide links like this, anything enclosed in square brackets, followed by a URL enclosed in parentheses, will be rendered as a link, a hyperlink. So you'll notice that I'm going to provide a link to the automatically published documentation, which we'll get more into here in a little bit. Right, so this is just, the headline front page of your repository for your project. Next, I mentioned the documentation generator, Ford. So in the doc folder, I've got a file called, and you can really name this anything, but I call it frontmatter.md. And so the first section here is settings for Ford. And then you can write additional markdown, and this will all be rendered on the front page of the documentation that Ford generates. So we have a file there. Let's step back 1 second where we were talking about FPM, right? So I have an FPM project, which means that I can run the command FPM test, right? Because we have tests, and it will compile my project and run the tests, and it tells me that the tests passed. Now, because I have automatic documentation generation with the Ford tool, I can run Ford and give it the name of the file. I misspelled it. Ford front matter. So, and we give it the name of the file where our settings and the front page are. And Ford will scan our project and generate documentation by parsing the source code and extracting any of those special comments. And I've told it to put the documentation in a subfolder in the doc Ford site. So all of the documentation gets generated here, and it generates an HTML like website that is the documentation. And we'll take a look at that in a little bit. Next, because we're using Git, certainly committing, including files in our repository that are generated automatically. Specifically, the build folder, that's where FPM is going to put all of the output from compiling your code, and the documentation that is generated automatically. We don't want either of those to inadvertently be added to the repository, because we can always generate them whenever we need them. So that's the basics of how we set up the project. But now, how are we going to take advantage of the tools that GitHub provides for us in terms of the automation? The first thing that we of note is that in a special folder that starts with .github in a subfolder called workflows, any .yml, any files that end in .yml that are their YAML files, which is a special syntax for data storage, that kind of thing, it will execute each of these files in a certain way. So we'll walk through a couple of these, and you'll kind of get the idea of what's going to, how use of these files. So the first thing is you can give it a name. So the name of this automation that I would like GitHub to run when I put code on GitHub is I want to just build and deploy the documentation. And I want to do this specifically anytime I push code to GitHub or anytime somebody opens a pull request in the repository to the repository. Then we're going to give it the jobs associated with this automation. I'm going to call it documentation, and it runs on Ubuntu, right? So I'm just going to use Linux for building and deploying the documentation. We can specify variables that we want to be able to use further down in the code. We're going to say that the Fortran compiler that we want it to use is gfortran, and we're going to use version 12 of gfortran. Then we give it the steps to perform as part of this automation. And each one, we give it a name. So the first thing we want it to do is check out the code. So there is an action, some automation that somebody's already written for us that knows how to check out your source code. So basically, it's going to, wherever this automation happens to run, it will go and fetch our code for us from GitHub. Next, for the purposes of deploying the documentation, building and deploying the documentation, there's some software that needs to be installed on the machine that isn't installed by default on GitHub. Specifically, we need a Fortran compiler. Ford is a Python tool, so we need the Python dev package. And Python also makes use of an external tool called GraphViz to generate some of the graphics that it can make. Then we need to install Ford, and lately there has been a bug in Ford where we really have to pin the version of one of its dependencies, specifically Markdown, to this particular version. Apparently something broke in the newer version of the Markdown library that Ford doesn't work with it correctly. Next, we can just build the documentation. So we can run the Ford tool on our Ford settings file. Once the documentation has been built, we can upload it. And again, somebody has already written an automation tool for us that knows how to upload things to GitHub. So basically what this is going to do is it's going to create a zip file that GitHub will keep track of for us that can be downloaded if somebody goes to a page on GitHub where this action has been run. So it will show the screen output from running all of these scripts and any of the artifacts that are uploaded. In this case, it's just going to be a zip file with our documentation, right? So we can give it a name. So the name of the zip file is going to end up being documentation.zip. And we want it to take everything in this folder, the doc Ford site folder, because that is where Ford is going to generate our documentation for us. So we want it to say, grab everything in there, put it in a zip file, and name it documentation. And if there's nothing in there, we want it to report an error to us. Next, there's a broken link check. So we only really need to do this on the main branch. So this github.ref is going to be the branch or commit or what have you that this automation is being run against. And so we only need to do this if we're on the main branch. And again, there's another action that somebody has written for us that will check for broken hyperlinks. So we say to that file that we generated in previously, the front matter, right? So that file, which is in the place where this automation has been run, site index.html file, start there and follow all of the hyperlinks and make sure that they work. And presuming that our documentation was able to be built, uploaded, and doesn't have any broken hyperlinks, right? That's an aspect of how these scripts are run, is it executes the steps in order, and if any of them fails, it will stop and report an error. And so assuming that all of that went well, we can finally deploy our documentation. There is yet another action that somebody else has provided for us to be able to do that. If this was a push to the main branch of the repository, right? So we only want to deploy new documentation for the main branch and only when the code has been pushed to it. We're going to, the way that this works is it creates a new branch in your repository with the name GitHub gh-pages that just contains the contents of that, right, that doc Ford site folder. And so this is a feature called GitHub Pages, and there's some settings on in your repository when we go to GitHub to start looking at how this all starts to play out. You tell it, uh, I want you to host this as a static website. Here's all of my HTML files. They're on this branch. And so it basically makes a public documentation website freely available for you. And so this is how we can automatically deploy documentation for our project, which makes your project seem much more polished and professional. Next, we have a tool that can execute our tests for us automatically. So let's take advantage of that. Every time we send code up to GitHub, we can let GitHub run our tests for us and make sure that nothing broke. So this is another automation that I'm going to call build and test. Anytime code is pushed or somebody opens a pull request for the repository, I want you to run this job. So the job is build and test. It's going to run on, and here's a new feature of how we can use uh, how we can use GitHub Actions. We can say that there's a strategy that our operating system is a matrix of things, right? So we can give it a list of the operating systems that we would like it to execute this automation for. So instead of just saying we want to use Ubuntu, we can say, no, I want you to do this action for each of these operating systems. So we can use Linux, the Ubuntu operating system, Mac OS, the latest version, and Windows, the latest version, to test our code. So now we can test our code on all three of the major platforms automatically. We're again going to be using version 12 of Fortran. So that's that same environment variable. So that's a variable that we can have. We're going to use that checkout code action again. There is an action available for setting up FPM on the in the environment where the actions get run. So that one's available. And that's just going to go and get and install and make sure that the latest version of FPM is available so that you can use it in your action. Now, we are running on different operating systems. So installing the needed tools will be different for each different operating system. So we have 3 different steps here, but we only run them for the particular operating system. So we can say that if the thing we're running for is Ubuntu, here's how we install the tools that we need. And basically we just need Fortran, and because we're using a specific version, we need to make sure that that specific version is available under the name just Fortran. Similarly for Mac, this is how we install and make sure that Fortran is available on Mac, and here's how we do it for Windows. Now in this instance, we're not using the native Windows environment. I have not been able to find a convenient way that the FPM action and Fortran can be installed on Windows together. But this 2 environment actually makes it really easy. So the FPM action will use the MSys2 environment. We'll make sure that FPM is available in this environment, and then this environment has an action available that will make it easy to install Fortran. Now there is a slight difference between how we can run our tests in Linux and Macs versus Windows. So if this is Linux or Mac, I have found it is often quite useful to know what version of Fortran is actually installed and where is it installed, so we know what we're running. And then we can just run FPM test, and this will run our test suite for us. Now on Windows, execute is still identical, but we need to be able to tell it that we want it to use this particular shell, not the default shell on Windows. So we want it to use the MSys2 shell. And so now, anytime we push code up to GitHub, these automations will run and make sure that our code is not broken and publish any documentation that that we have. So let's jump over and look at the GitHub repository on a web browser. So here's the repository where this project that we've been looking at is published. I will put a link down in the description so you can go and check it out yourself. But the front page renders our readme.md file. It's at the top level, and we can see that it renders a link here. This little check mark here is saying that it ran all of our automations, and we can see what those automations were, and we can even go and look at the details about how those automations were executed. And provided they all executed successfully, there will be check marks next to them. If they're still actively running, it will show a yellow circle, and if they failed, it will show a red X saying, and this check mark will be a red X if any of them failed. Or if any of them are still running, it will be the yellow circle. So let's go and look at, well, what does the build and deploy documentation look like? So you'll see that it basically lists out all of those steps that it went through, and you can expand and look at the output from running each of those steps. So for example, building the documentation, you can see that it runs forward. Here's the output from forward. It uploads the documentation, does all of the other things, and then finishes. And so if we go and look somewhere, it will show this uploaded somewhere. Although perhaps I'm not seeing it. Ah, here we go. So I think if we say, so from the front page, build and deploy documentation. So it will not show it on that page, but if you, aha, I saw it. If you click the back arrow here, it will go back to the workflows. So this is just you can click the actions button. It'll show you all the actions. It'll show you the different names of the actions that it's executed. So if I specifically want to look at the build and deploy documentation, it'll show you what branch did it execute that action for, and what was the most recent commit that it executed that action for. And so if I click on one of those, it will show you, oh, here's what the workflow looked like. There are some warnings here. Apparently, some of these actions are out of date. But at the bottom, there's the artifacts. So this is the documentation that it generated, and it was uploaded. We can go back to the front page, and we can look at one of the other ones. Let's look at the Ubuntu build and test. So you can see that it did not install the dependencies for Mac OS or Windows because of that if statement that we had there. And it ran the build and test for Linux, but not Windows. And so what does the build and test look like? Well, it told us, well, this was where we found Fortran. This was the version, right? Because we said that was what we wanted it to execute first. And then this is coming from FPM, right? So FPM is going to build our code for us and then run the test and test pass. So we can always go and see what happened when the automation executed. So if anything goes wrong, you can go and see here, what was it that went wrong? You can go find what the error messages were, etc. So now that we have it executing our code and building and deploying our documentation for us, there's one setting that you're going to want to go and make sure you enable. So go to Settings and Pages, and tell it that you want to deploy your pages from the specific branch. Until then, the site won't be live, right? There won't be anything published. But once you get the settings set right, then it will tell you where is your site, what's the URL to get to the documentation that you published. And you can either click on that link, or I like to put a link to the documentation in the repository. So we can click on that link. And then this is what the Ford documentation will look like. It will have listings of some of the source files and modules. If your project is large, these listings get truncated without really much indication that that's not an exhaustive list. But the same lists are available as individual pages that you can get to in the menu up at the top, right? So I can go click on the source files. Often it will give me the source code. So there's the source code. If we want to look at the procedures, so the only procedure we have is create greeting. So it grabbed the documentation string from the source code, parsed the source code to understand that the argument is a character variable with the name, right? So there's the arguments, and the return value is an allocatable character, right? So you can get lots of your documentation about your library for free, basically for free. And it's automatically generated and automatically deployed and made public so that you can put a link to it in the README. So that concludes all of the automation and setup for the tools that I like to use to take advantage of that's available on GitHub. I hope you found that useful. If you did, make sure you like the video, click that subscribe button if you want to see more content from me as I put it together, and hope you enjoyed the video.